Good day and welcome to today's class. Today's class is a continuation of our previous classes on SURDS. In our previous classes, we have looked at the following objectives. We have been able to differentiate between rational and irrational numbers. We have also been able to apply the rules of additions and subtraction of SURDS in solving SURD problems. I have equally applied the rules of multiplication and division of SURDS in solving SURD problems. At the last class, I was able to explain the concept of conjugate binomial SURDS. In today's class, we shall take the fifth objective, which says apply the concept of SURDS to problems involving trigonometrical ratios of angles 30 degrees, 45 degrees, and 60 degrees. And we refer to these angles as special angles. At the last class, where we looked at the conjugates of binomial SURDS, I left the class with an assignment where I said you should simplify the expression 1 divided by root 5 plus root 3 minus 1 divided by root 5 minus root 3. I'm going to give you the solution to this problem. Thereafter, you compare it with what you have done and see if you get it right. Otherwise, you do the necessary correction. So in solving this, since these are two fractions, I'm going to look for the LCM of the two denominators. And the LCM of the two denominators is said to be the product of both denominators. And if you look at them, they are conjugates of each other. So this is going to be root 5 plus root 3 to be multiplied by root 5 minus root 3. So when you divide root 5 plus root 3 times root 5 minus root 3 by root 5 plus root 3, you are going to have root 5 minus root 3. And root 5 minus root 3 times 1 still gives us root 5 minus root 3. Minus, you do same to the second term. This says root 5 plus root 3 times root 5 minus root 3 divided by root 5 minus root 3 is said to be root 5 plus root 3. So into bracket root 5 plus root 3. I'm going to simplify both the numerator and denominator. So when you open the brackets, this is equal to root 5 minus root 3. Use the minus sign to multiply every term in the bracket. Gives us minus root 5 minus root 3. All divided by, you apply the idea of difference of two squares in solving the denominator. And this gives us 5 minus 3. So when you simplify further, by collection of like terms, you agree with me that plus root 5 minus root 5 is said to be 0. While we are left with minus root 3 minus root 3. And minus root 3 minus root 3 is said to be minus 2 root 3. All divided by 5 minus 3 is said to be 2. And 2 can divide both the numerator and denominator. 2 into itself is 1. 2 into 2 is 1. Leaving us with minus root 3 as our answer. So this is the solution to the assignment I gave you while we move into applications. In today's class, we shall be looking at the applications of SURDS in solving triangles, and which can be said to be trigonometrical ratios of special angles. By special angles, I mean angles 30 degrees, 45 degrees, and 60 degrees. Now, let's consider a right angle triangle. In a right angle triangle ABC, where angle B is said to be of 90 degrees and angle C is said to be theta, with reference to angle theta, side AB can be said to be the opposite side because it is the side that is facing angle theta, while side AC, with reference to angle theta, is said to be the hypotenuse side, which is abbreviated as this, because it is said to be the longest side, or the side that is facing the angle 90 degrees, while the third side is said to be the adjacent side. Now, when you consider the trigonometric ratio of this triangle, trigonometric ratio gives the relationship between the angle and any other two sides. So in getting the trig ratios, which is the relationship between any two sides of the given right angle triangle and the angle theta, we refer to it as trig ratios. So we refer to sine theta, that is the sine of angle theta, is said to be the ratio of the opposite side to the hypotenuse side of the angle, and this can be said to be equal to side AB over side AC, and we refer to this as sine theta. So sine theta in essence is said to be the ratio of the opposite side to the hypotenuse side. Also, if you consider the relationship between any other two sides, I've done the relationship between this side and the opposite side and the hypotenuse side. Also, cosine theta is said to be the relationship between the adjacent side of the right angle triangle to the hypotenuse side, while the relationship between the opposite side to the adjacent side is said to be tan theta. That is, tan theta is said to be equal to the ratio of the opposite side to the adjacent side, and we refer to this as the trig ratios. So in essence, what we have is that sine theta is said to be equal to the relationship between the opposite side, or the ratio between the opposite side to the hypotenuse side of a right angle triangle, while cos theta is said to be the ratio between the adjacent side and the hypotenuse side, and tan theta is said to be the ratio of the opposite side to the adjacent side. So this is going to help us in getting the trig ratios of these special angles. So let's look for the trig ratios of angle 30 and 60 degrees. For us to get the trigonometric ratios of angle 30 and 60 degrees, so let's consider this equilateral triangle ABC, and we said an equilateral triangle is a triangle with all sides being equal, as well as all angles being equal and equal to 60 degrees. So this is said to be 60 degrees, this is also 60 degrees, and this is also 60 degrees. Now with sides also being equal to be 2 centimeters each. So if these are 2 centimeters, now I want to get the trig ratios of these angles. I'm going to draw a bisector from A to point, let me call it N, and this gives me the height of the triangle ABC. And when you draw a bisector, this is said to be angle 90 degrees. So if this is a bisector, it therefore means that this angle is said to be 30 degrees and this is 30 degrees. For a bisector divides an angle or a line into two equal parts. So if this is dividing, if this point N is said to be the midpoint of BC, it therefore means that BN is said to be 1 cm and NC is said to be another 1 cm, making it 2 cm. Kindly like our videos if you are still watching to this point, while we encourage you to subscribe if you are yet to do that. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. We also recommend that you use the comment section to interact with us on areas that are not clear to you. You can also share the links with your friends to also benefit from this project. So in order for us to get the trig ratios of these special angles, we need to as well get to know the dimensions of every side. We have that of AB, BN, NC, and AC. But what is the length AN? Since ABN is a right angle triangle, it therefore means that applying the Pythagoras theorem, which says that in a right angle triangle, the square of the hypotenuse side is equal to the sum of the squares of the other two sides. That means that side AB squared is equal to side BN squared plus side AN squared. But we have it that side AB is said to be 2 centimeters. That means 2 squared will be equal to BN is 1. That is 1 squared plus side AN squared, which is what we are looking for. And we tag that as H. It therefore means that 4 is equals to 1 squared plus H squared. Making H squared the subject of the formula, you are going to have 4 minus 1 squared is 1 is equals to H squared. And 4 minus 1 is said to be 3. That means 3 is equals to H squared. And when you make H the subject of the formula, by finding the square root of both sides, you agree with me that H is equals to plus or minus root 3. But we shall take the absolute value of that. So if H is equals to root 3, it therefore means that this side is equals to what? Root 3. Now, for us to get the trig ratios of angle 30 degrees and 60 degrees, we shall consider the sides and the angles. So, for trig ratios of sine 30 degrees, sine 30 degrees is said to be the ratio of the opposite side to the hypotenuse side. Now, this is angle 30 degrees, or this is angle 30 degrees. Since angle ABN is equal to angle ANC, you can use any of them. Okay, so when we consider angle ABN, sine 30 degrees now is said to be opposite over hypotenuse. And where is the opposite side to angle 30? Is said to be 1. So sine 30 degrees is said to be 1 divided by the hypotenuse side is said to be 2. So 1 divided by 2 is said to be equal to sine 30. You can as well punch your calculator to confirm it, and it gives you 0.5. So you put it as 1 over 2 or 0.5. While cos 30 degrees is said to be equal to the ratio of the adjacent side to the hypotenuse side. So where is the adjacent side to angle 30 degrees? If this is the opposite, this is the hypotenuse, then this is the adjacent. So adjacent is root 3 over 2 for cos 30. While tan 30 degrees is equal to the ratio of the opposite side to the adjacent side. And the opposite is said to be 1 divided by the adjacent is said to be root 3. So when you rationalize tan 30, it is said to be equal to root 3 over 3. That we have talked about. So sine 30 degrees in short form is said to be 1 over 2. Cos 30 degrees is said to be root 3 over 2. And tan 30 degrees is said to be root 3 over 3. If you punch the calculator, this is what you are going to have. Also, the trig ratios for angle 60 degrees, we have sine 60 degrees, cos 60 degrees, and tan 60 degrees. So for sine 60 degrees, we say it's the ratio of the opposite side to the hypotenuse side. And when you consider it, this is angle 60 degrees. The opposite side to angle 60 degrees is root 3. So this becomes root 3 divided by the hypotenuse side is 2. While cos 60 degrees is said to be the ratio of the adjacent side to the hypotenuse side. And what is the adjacent side to 60 degrees? If this is opposite, this is hypotenuse, this is adjacent, that gives us 1 over 2. While tan 60 degrees is said to be the ratio of the opposite side to the adjacent side. And this is equal to opposite side to angle 60 degrees is said to be root 3. So this gives us root 3 divided by adjacent side is 1, root 3 over 1, and root 3 over 1 is said to be root 3. Now, let's confirm something. If you look at sine 30 degrees, you agree with me that sine 30 degrees, which is root 3 over 2, is equal to cos 30 degrees, while cos 60 degrees, which is 1 over 2, is equal to sine 30 degrees, and tan 30 degrees, tan 60 degrees is said to be the reciprocal of tan 30 degrees. So that is the relationship between trig ratios of angle 30 degrees and 60 degrees. Now, let's look at the trig ratios of 45 degrees and 90 degrees. For you to get the trigonometrical ratios of 45 degrees, we shall consider an isosceles triangle. An isosceles right angle triangle is said to be a triangle with two sides being equal. So I shall call this of side 1, 1, and let's call this is the hypotenuse. And if you use the Pythagoras theorem in solving for the hypotenuse side, you agree with me that this is said to be root 2, where this is 45 degrees, or this is also 45 degrees. So we can use an isosceles triangle to get the trigonometrical ratios of 45 degrees. So if we consider the sine 45, which we said it is equal to the ratio of the opposite sides to the hypotenuse side, sine 45 degrees is said to be, sine is opposite over hypotenuse, which is said to be 1 over root 2. And 1 over root 2, when you rationalize it, is said to be equal to root 2 over 2. Remember, we don't leave an irrational number as a denominator. So whenever you see an irrational number as the denominator, always rationalize it. Also, cos 45 degrees, which is said to be the ratio of the adjacent side to the hypotenuse side, is said to be equal to, this is the opposite to angle 45, this is the adjacent, so we still have 1 over root 2, which is equal to root 2 over 2. While tan theta is said to be equal to the ratio of the opposite side to the adjacent side, and this is said to be equal to, this is opposite and this is adjacent, is said to be 1 over 1, and 1 over 1 is said to be 1. Also, I would like you to note that tan theta, which is said to be the ratio of the opposite side to the adjacent side, can also be said to be equal to sine theta divided by cos theta. And if you look at it, sine theta is said to be opposite over hypotenuse, which when divided by cos theta, which is adjacent over hypotenuse, will give you opposite divided by hypotenuse times hypotenuse divided by adjacent. And if hypotenuse will cancel itself, it leaves you with opposite over adjacent. And the ratio of opposite over adjacent is said to be tan theta. So we shall be using these trig ratios in solving triangles. So we shall take an example now. Example 1 says, in triangle PQR, side PQ, which is this, is given to be 5 centimeters. We are asked to calculate side QR. Side QR is said to be this side. Let's call it X. So we are to find sine QR. With the knowledge of trigonometrical ratios, we can then apply this in solving for X. So all you need to do is get to know the relationship between the 3 sides, and then you can solve for X. So with regards to angle 30 degrees, 5 is said to be the opposite side. So this is opposite over adjacent, and opposite over adjacent is said to be tan theta. So it therefore means that 5 over X is equal to tan 30 when you substitute. So I'm going to make X the subject of the formula by cross multiplying, and then I'll get my value for X. And when you do that, you have X tan 30 degrees is equal to 5 times 1, which is 5, and X is equal to 5 divided by tan 30 degrees. So X will be equal to 5 divided by, what is tan 30? If you go back to our proof, you will get the value of tan 30. That we got tan 30 to be what? Root 3 over 3. So without the use of calculator, you can therefore substitute it as root 3 over 3. And then you simplify. This becomes X is equal to 5 times 3 over root 3. You simplify further. This gives us 5 times 3 is 15. 15 divided by root 3. Remember, this is an irrational number and it cannot be left at the denominator. So we rationalize it by multiplying both the numerator and denominator by root 3. And when you do that, this is said to be equal to 15 root 3 divided by 3. And 3 can divide. 3 into 15 is 5, leaving us with our answer that X is equals to 5 root 3. So what does that mean? It means that this side is said to have the value of 5 root 3 as your answer. Kindly like our videos while you watch. While we recommend that you subscribe to our channel if you are yet to do that. We also advise that you use the comment section to interact with us on areas where you are still confused. You can also share the link with your friends so that they can also benefit from this project. Example 2 says we should calculate the marked sides in triangle XYZ. This is triangle XYZ, and the marked sides they are talking about is side XZ, which is V, and side XN, which is U. Now, since this is a right angle triangle, we can therefore apply the trig ratio. How do I get that? When you talk about triangle, two things comes in mind, which are the trig ratios and the Pythagoras theorem. You can use these two combined in getting any sides of a right angle triangle, so long as it is a right angle triangle. So, how do we get the sides? We'll start by looking for U. Why do I want to get U before V? Because if I consider triangle XYN, we have two sides, one side given and one angle. We only have one side, which is we are asked to find. But in triangle XNZ, no side is given, only the angle, included angle, is given. So we ought to get U first, which aids us in getting V. So let's get the relationship between U, 8 centimeters, and 60 degrees. Now, this is 60 degrees. U is said to be the opposite side to 60 degrees. So I'm going to say opposite divided by, while 8 cm is said to be the hypotenuse because it's said to be the longest side of triangle XYN. And since this side is 90 degrees, it therefore means that here is also 90 degrees. So the opposite side to the hypotenuse side of triangle XYZ is said to be equal to sine theta. So what's the opposite side? U divided by 8 is equal to sine 60 degrees. Now make U the subject of the formula. We have it that U is equals to 8 sine 60 degrees. And we have already proved the value of sine 60 degrees. You can go back to the trig ratio and get the value of sine 60 degrees. For the value of sine 60 degrees is said to be root 3 over 2. So sine 60 is root 3 over 2. We now substitute it in this equation, and this is said to be U is equals to 8 times root 3 over 2. Then you can simplify. And when you simplify this, you agree with me that 2 can divide. 2 into itself is 1. 2 into 8 is 4. So U is said to be 4 root 3. So our value for U is said to be equal to 4 root 3. Now, since we have gotten our value U, we can use U angle 30 degrees to get our value for V. So when you do that, you also create a relationship between U, V, and 30 degrees, and then solve for V. Now, you have it that U is the opposite to angle 30 degrees. So we have it that opposite divided by hypotenuse is equal to sine theta, which we have established. And this now becomes opposite side is said to be 4 root 3 divided by the hypotenuse side, which is unknown, V, is equal to sine 30 degrees. And we then make V the subject of the formula by saying V is equal to 4 root 3 divided by sine 30. When you cross multiply and divide, you then look for the value of sine 30. V is equals to 4 root 3 divided by sine 30. And if you look at it, sine 30 is said to be 1 over 2. From our trig ratio, we got sine 30 to be 1 over 2, or 0.5. So you can substitute it in this equation by saying 1 over 2. So simplifying this further, we have it to be equal to 4 root 3 times 2 over 1. And V is said to be equal to 8 root 3. So our value for V is said to be 8 root 2. So V here is equal to 8 root 2. Kindly use the comment section to ask questions where you don't understand. And if this pleases you well, you can give us a thumbs up using the comment section. So that is our answer. We have been able to get the marked values U and V. That brings us to the end of today's class. In today's class, we have been able to use the application of SURDS in solving triangles, and we have also learned the trigonometric ratios of special angles of 30 degrees, 60 degrees, and 45 degrees, of which we say the trig ratio between the opposite and the hypotenuse side is said to be the sine of the included angle, and that of the adjacent side to the hypotenuse side gives us the cosine of this angle, as well as the ratio of the opposite side to the adjacent side is said to be the tangent of that angle. Thereafter, we are able to get the trig ratios of angle 30 degrees, 60 degrees, and 45 degrees. In our next class, we shall be taking more examples as regards to solving triangles. Kindly like our videos if you are yet to do so, while we encourage you to subscribe to our channel. Also, we encourage you to turn on the notification bell so as to be notified whenever a new video is being uploaded. You are to use the comment section to interact with us on how you feel about the class, while you're encouraged to also share the link with your friends so that they can also benefit from this project. Thank you and do have a nice day.